A simulation open here from the University of Colorado, and it is a gas properties simulation. There are 4 gas properties or variables that we can manipulate in gas problems. One being the volume of the gas, represented by the tank, and we can increase or decrease the volume of the tank with having that little spaceman dude there move back and forth. Or maybe he's a scuba diver, I don't know. He's wearing a tank of some sort. We can change the temperature. We can add or remove heat to change the temperature. The pressure is the third one. We don't have a whole lot of control over that at this point. And finally, we have the amount of gas, or the number of molecules of gas. So let's get the thing rolling here. I'm going to pump this one time, put some air into the tank. There, the gas molecules are represented by the little blue dots, and we notice that, hopefully you notice that once they got in there, the temperature went from 0 to 300 Kelvin. The pressure has gone up to almost 0.8, there went 0.8 atmospheres, and the volume has stayed the same at this point. The particles are moving at a particular speed. They're not all the same speed, but on average, their speed is what causes this pressure or this temperature to be 300 Kelvin. Now, what can we do to change the pressure of the gas? All right, first thing we can do, let's change the volume. Let's see what happens by changing the volume of the gas. So I have the dude push and make it smaller. Notice what's happening to the pressure as the volume gets smaller, the pressure is going up. Okay, you can see the temperature is going up, but we're really not focusing on that. We're just focusing on the pressure. And notice that as the pressure has gone up, the particles are moving much more rapidly. They are hitting each other in the walls of the container fast or more frequently and with more energy, and that is what's causing the pressure to go up. The result was also the increase in temperature, but really we're not talking about that at this point. If we make the volume get smaller, or get larger, sorry, as the volume gets larger, the pressure gets smaller. So the relationship between pressure and volume is an inverse relationship. When one goes up, the other goes down, and vice versa. We'll reset. Let's throw in a pump of air and let things get back to equilibrium. And each time you pump that thing, you don't always get the same amount of air. This is pretty close to the one I had before. But at this point, we're about to equilibrium, right about 0.8 atmospheres, 300 Kelvin. If we change the temperature, let's add some heat and see what happens to the pressure. Temperature's gone way up. Pressure now is going up because the temperature, remember, is measuring the kinetic energy or the speed of the particles. And so as the temperature has gone up, that's made the particles go faster, which causes them to hit each other and the walls more frequently and with more energy. Okay. If we take away some heat, I guess we're using ice cubes to do that. We drop the temperature, and the pressure also goes down. Okay. We could probably do some math at this point if we really wanted to. So if we say that the temperature at this point is 275 K and the pressure is 0.73 atmospheres, and then we increase the temperature, let's increase it up to 350. Oop, wait, where's 350? How about 370? At a temperature of 370 Kelvin, the pressure is 1.1 atmospheres. So write those two numbers down, and there'll be some instruction on what to do with those 4 numbers, I guess, and the space on the paper. All right, let's reset. Put in the one pump. So we've seen so far that if we change the volume, we change the pressure. When the volume went down, the pressure went up. When the volume goes up, the pressure goes down. temperature and pressure were a direct proportion, where when the temperature went up, the pressure went up. When the temperature went down, the pressure went down. Let's throw in a pump of air. Get the thing going. We're about to equilibrium there at about 0.9 atmospheres, temperature at 300 Kelvin. And then let's see what happens when we put another pump of air in. Try to go about the same size. Won't get it exact. It was just under 1 atmosphere before. We put in some more air, and the pressure has gone up from there. So more air is going to cause the pressure to go up. And the reason the pressure goes up when you add more air, notice that there are so many particles in there now, and they don't have very far to go before they bump into something. So we're getting much more frequent collisions and much more energy when they collide because they don't have to move very far. Okay. Reset. Let's just run one little experiment. There's 3 pumps of air. And let's see what happens when we just keep shrinking that volume down. Let's make it as small as we can get it. See now the pressure is going up. Temperature is also going up. Okay. And look, we've blown the lid off the thing. How about that? So that's the end of the video. Do the questions that are attached.